Hi, this is Sim.
Hi, this is Chris.
I'm Tommy.
Hi, I'm Stefan Mayer.
And this is Team TBD.
Hello, my name is Chris, and I will be going through the requirements for Team TBD's final project. For this project, we are required to build a robot with at least 2 drive wheels on it. This robot also must be tetherless, meaning the robot must carry its own power supply using batteries. Another task was to have a vertically moving arm. For this, our team decided to go the extra mile and design a robotic arm that used inverse kinematics to move up and down. Our final requirement was to have the arm be able to move on a horizontal axis using a stepper motor or a DC brush motor running counterclockwise or clockwise. For bonus points, our team decided to use the onboard Wi-Fi module to connect to a tablet in order to control our robot. Now I'll send it over to Sim to show you how it works.
Hi everyone, Sim again. Let's take a look at our robot in action.
Hello, this is Tommy again, and I'll just be explaining a little bit about the inverse kinematics of our robotic arm. Since servos are positional actuators, the inverse kinematics for our robot arm consisted of finding the angles that correspond to a certain x and y position in its plane. We did this by setting up a simple statics problem and using the law of cosines to solve for the angles needed as well as the relationships they had with one another. From there, a linear relationship between the input pulse and the output angle of the respective servos was derived, so that our controller would be able to take an input of an x and y coordinate and output the angles needed to get that position. A similar method was used to find the kinematics for the wheels.
Hey there again, I'm Stefan. I'm going to be talking you through the code. Let's dive right in. Alright, so this is the code. We programmed it in C. It works with the Wi-Fi website. Let's take a look at that. Alright, so this is the remote control Wi-Fi website. So the joystick on the left drives the robot. The buttons in the middle opens and closes the gripper. The joystick on the right moves the arm forward and backwards and left and right, and the slider moves it up and down, and the lock locks the arm from going left and right. And the top right, it shows when you're connected. Since this is a Wi-Fi page, it can be used on a variety of devices. It works on your computer, on your tablet, on your phone, on someone else's phone.
Hey, that's my phone.
On someone else's computer.
Hey, are you on my computer?
I think you get the idea. Well, let's go talk about the code. Alright, so we're back. So the top part of the code just initializes values for the pins and important information for the Wi-Fi. And then the first part of the main function is we start the listening for Wi-Fi, and then we run all these functions in different cogs. So we move the inverse kinematic arm, we move the stepper motor, we smooth the input, and we drive the robot. Then we center the arm to point straight up and down, and the rest of the code listens for the input. So the set value function, all it does is it sets up the stepper motor to drive 3200 steps per rev. Then the moving stepper motor function, all it does is it moves the stepper motor to a desired angle from the X direction of the right joystick. The smoothing input, all that does is it smooths the input so that if you jerk the joystick or the slider, it won't affect the robot. Then we have an angle to pulse function, which it takes in an angle in degrees and gives us a pulse for the servo to achieve that angle. Then the calculate inverse kinematic angles, all it does is it takes the math from inverse kinematics and it gets the angles for both servos. The move arm function, all it does is it utilizes the calculate inverse kinematic angles, and then it converts that angle to a pulse so that we set a desired servo angle. Then the moving inverse kinematic arm, what this does is it moves the arm using the right joystick and the slider. The drive robot function, all it does is it takes the left joystick's X and Y directions and it drives the wheels of the robot.